This video is going to walk us through how to factor quadratic expressions. So a few reminders. A quadratic expression is a polynomial of degree 2, which means that the highest exponent is a 2. And when it's written in standard form, it's ax squared plus bx plus c. So for example, we're going to see maybe something that looks like 3x squared plus 4x minus 6. Okay, that would be in standard form. So the value of a would be 3, the value of b would be a positive 4, and the value of c would be negative 6. So we're going to be, as we go through these problems, identifying the value of a, b, and c. So those are all going to be either the coefficients or the constant at the end of the problem. Factoring is the process of rewriting a polynomial as a product of factors. So we have already seen what factored form looks like. That's going to be when we have two sets of parentheses most of the time, and it might look something like this. Okay, so what we're going to be doing today is taking an expression that is in standard form, which is this, and moving it and changing it into factored form. So there are really 4 different steps to factoring, and then 5 I'm going to show you how to be able to check your answer. And I will walk through these steps when we do the first example. So I would maybe continue to look back in your notes at the steps as you're going. To sum it up, you make sure it's in standard form, you check for a GCF. This star over here to the right is going to be how we set up every single problem, and then we'll use that to be able to write the factored form. So a couple more things that are important before we get into the first example. The first thing is that not all quadratics are factorable. So we will need to learn more methods as we move along in this unit because factoring is not always going to work. Okay. The second thing that is super important for today is that we need to make sure that the value of a is always positive. So our leading coefficient, ax squared, cannot be a negative number. If it is a negative number, I'll show you how to factor out a GCF and making sure that that GCF is negative so that a becomes a positive number. Okay. You should never have a GCF within your factors. So a GCF is a number that all of your terms are divisible by. So for example, if I gave you 3x minus 6 as one of your factors, these are both divisible by 3, and so that would tell you that something is wrong. You should never, ever, ever end up with a GCF within your factors, okay? And then we're going to have special cases, and that's going to be a separate video. But if you're factoring and you don't have a constant, then C is equal to 0, and you're just going to factor out a GCF. If you're factoring and you're missing your B value and Bx is equal to 0, then that's going to be a special case, and I'm going to talk about how we can factor that. So example 1, 9x squared plus 42x minus 72. I would encourage you to either look back in your packet at the steps to factor that are written, or you can periodically go back in this video, but I'm going to read the steps as I am going through this example. So step number 1 was to always make sure that the quadratic expression is in standard form. Okay, so my ax squared term is first, my bx is second, and the constant is at the end, which this is in standard form. Step 2 is to check for a GCF. This is a really, really, really important step. If you start to factor and your numbers are really, really big, it could be that there was a common factor at the beginning that you forgot to divide out of the expression. So GCF stands for greatest common factor, and that would be a number that 9, 42, and 72 are all divisible by. Now we have to be careful here because it might be that you come up with a number that these are all divisible by, but then the answer that you get those numbers are also all still divisible by something. That means that you did not take out the greatest common factor. So I would always start with the highest number you can think of. So for example, on this one, 9 would be the biggest possible number. So you can divide 9 by 9. Can you divide 42 by 9? And can you divide 72 by 9? Well, 42, 9 doesn't go into 42, okay? So then what's the next biggest number that would be, that 9 would be divisible by? And that would be 3. And when you check, all of these terms are divisible by 3. So that means that 3 is my greatest common factor, and I need to divide that out of this problem. So now 9 divided by 3 would be 3x squared. 42 divided by 3 is 14. And 72 divided by 3 is 24. Now, the GCF can't just magically disappear. We're taking an expression and we are rewriting it in factored form, meaning we're not changing it. It's the exact same expression. So the 3 needs to stay outside. And if I were to distribute it, I would get my original problem. All right, so now step 3 is to create the star. All right, so to create the star, we need to know what the values of A, B, and C are. So for this problem, A is 3, B is 14, and C is a negative 24. Okay, so A, B, and C are just the coefficients or the constant at the end. So from our star, and the top of the star is always A times C. Okay, so I'll write that over here to the side. The top is A times C, the bottom is B, and then underneath here is AX and AX. Okay, so for the top of the star, it would be 3 times negative 24, which is negative 72. B goes in the bottom, and then A times X goes underneath. So now it's what we've been practicing. Can we come up with two numbers that multiply to be negative 72 and either add or subtract to be 14? If the top number is negative, and you can look back at those reminders that we had, the little cheat sheet on if the top number is negative versus positive, what do my signs need to be? So if the top number is negative, then that means that the two numbers have to be opposite of each other. One has to be positive and one has to be negative. So I think it's really helpful to make a list of everything that multiplies to be 72. Because then you're going to have your answer written in front of you. You don't need to focus on the negative right now. That's going to come into play later in the problem. Right now, just what multiplies to be 72. So we could do 1 times 72, 2 times 36, 3 times 24. And don't guess and check in the calculator. You should be doing 72 divided by 2, divided by 3, divided by 4 would give me 18. Divided by 5 is going to give me a decimal, 6, 7. Then if I divide by 8, we get 9. And divided by 6 is 12. Once it loops back around and you start getting the same answer again, then you've come up with all of the factors. So one of these combinations will give me 14 if I either add or subtract the numbers. We know we're going to need to subtract because we know the numbers are opposite of each other, because that's the only way that I can multiply to be a negative 72. So 18 minus 4 is 14. So these are going to be 18 and 4. And then which one needs to be negative? So since the 14 is positive, I need the bigger number to also be positive. So this would be 18 minus 4. All right, once you come up with that, the next step is going to be to simplify, okay? And this is all kind of part of step 3, creating the star and simplifying these fractions. Negative 4 over 3x does not simplify. So you're looking at this like a fraction. This is negative 4 over 3. 18 over 3 does simplify because 18 divided by 3 is 6. So this would become 6 over x. Once you have your simplified fractions, we move into step 4, which says to write your factors as bottoms up. So when we write our factors, the x is always going to go up and in front. So for this one right here, it would look like 3x, and then it's a negative 4, so minus 4. And then my other factor would be just an x plus 6. And this is my answer. And it doesn't matter which order you write it in, so you could also write it x plus 6 and then 3x minus 4. It's a multiplication problem, so the order does not matter. And that's my factored form. Now, the great thing about factoring is that we can actually check this answer. So we are going to know if our answer is correct because I can FOIL it. Do you have to FOIL it? No. Foiling it will show you whether or not you get the original problem. It'll move it back into standard form. And so you can check that you have the right standard form. Now, I made one small error here. Oops. In that I forgot my GCF. So if you take a GCF out at the beginning of the problem, you have to make sure that that ends up in your answer. So since I have a GCF of 3, that should be in front. And I would have caught that when I went to go FOIL because I would have ended up with a final answer of 3x squared plus 14x minus 24 without the 3 in front. So just real quick to check this, if I FOIL, I would be multiplying 3x times x, so 3x squared, plus 18x, minus 4x, minus 24. Combine the 18 minus 4, so that would give me plus 14x minus 24, and then my GCF gets multiplied at the end. So if I multiply this whole thing by 3, that would give me 9x squared plus 42x minus 72, which was the original question. So then I know that my answer is correct. This is the factored form. So again, you don't have to FOIL the factored form. That is just to check and make sure that your answer is correct. All right, example 2, 2x squared minus 5x minus 12. So step 1, make sure that it's in standard form, meaning ax squared, then bx, then c, which this is. Step 2, check for a greatest common factor. So is there anything that 2, 5, and 12 are all divisible by? And it's okay if there isn't one. On this problem, there is no GCF. Okay, so it's not that there will always be a GCF, but it is imperative that you check for one before you start the problem. Okay, so since there's no GCF, I can jump to step 3, which is creating the star. So A is 2, B is equal to a negative 5, and C is equal to a negative 12. In the top is A times C, so 2 times negative 12, which is negative 24. B is on the bottom, and then AX is here and here. So now you're coming up with two numbers that multiply to be 24 that would add or subtract to be 5. This is similar to the last example where the top number is negative, meaning that the two numbers I come up with have to be opposite of each other. So what multiplies to be 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 will give me a decimal, and then 6 I've looped back around. So one of these is my answer. 3 and 8 will give me 5. And how do I get a negative 5? So if you need your answer to be negative, then the larger number would need to be negative. If you need your answer to be positive and you know you're subtracting them, then the larger number needs to be positive. So this would be a negative 8. Okay? Then you simplify if possible. 3 over 2x does not simplify. 8 over 2 would be 4 over 1. So negative 4 over x. And now from here, I can write my factors. So I would write 2x, and it's a positive 3. The bottom goes up in front, so x would be in front, and then minus 4. And this is my factored form. And then I am going to check this one real quick and make sure that we did it right. So to check it, you would FOIL and make sure that you get the same standard form that you have at the beginning of the problem. So this would be 2x squared minus 8x plus 3x minus 12. And this does make negative 5x. So check, we did it correctly. Example 3, we're factoring 6x squared plus 90x plus 300. So this would be an example where if you forgot to look for a GCF, then when you did the star, you would be multiplying 6 times 300, which is 1,800, and then you would be looking for factors of 1,800, which is a massive number. Now, could that happen? Possibly, but most likely it won't. So if you come up with numbers that are that big, chances are you forgot to check for a common factor at the beginning of the problem. So what can I divide 6, 90, and 300 all by? I would always start with the biggest number. So 6 would be the biggest number that goes into 6. And it does, you can divide 90 by 6 and you can divide 300 by 6. So 6 would be my common factor. Don't forget that the 6 does not disappear. It needs to stay in front of the expression. You are simply dividing it out of every term. So 6 divided by 6 is just 1, so x squared. 90 divided by 6 is 15. And 300 divided by 6 is 50. So now I have A is equal to 1, B is equal to 15, C is equal to 50, and we can create our star. So B goes in the bottom. This would be just 1x and 1x, and then A times C goes in the top. So 1 times 50 is 50. So now we are coming up with what multiplies to be 50, any factors of 50. So 1 times 50, 2 times 25, and 5 times 10. Of these, 5 and 10 will give me 15 if I add them. If everything in the problem is positive, then everything in the answer should be positive. If you don't have any subtraction signs, any numbers that are negative, then there are no negatives anywhere. So this would be 5 and 10. 5 plus 10 is 15. 5 times 10 is 50. If this is an x, this also is not going to simplify because it's just 10 over 1 and 5 over 1. So now my factors would be x plus 5 and x plus 10. And then our GCF from the beginning needs to come down in front of my answer. And this would be my factored form. Example 4, negative x squared minus 5x minus 4. So this one will trick people just because when we go to look for a GCF, there is nothing that divides into 1, 5, and 4 aside from just 1, which is not a greatest common factor that I would need to factor out. However, the leading coefficient right now is a negative 1, and when we are doing these factoring problems, it is very difficult if your leading coefficient is negative. So in order to get rid of that negative, not really get rid of it, but take it out of the problem at the beginning so that I can do my star would be to factor out a common factor of -1. So my GCF here would be -1. And what that will do is switch all of the signs. So -1 divided by -1 is +1. And now I'll be able to use the method of the star because my leading coefficient is positive. So then plus 5x plus 4. And I would just have a negative out in front of the parentheses. And if I distributed that negative, again, you would get the original problem. So I know that I factored that out correctly. So now A is equal to 1, B is equal to 5, and C is equal to 4. 5 goes on the bottom, x, and 1 times 4 is 4. Now this is a problem now that will also give students a lot of trouble despite the numbers being very small, because the only thing that they will come up with that multiplies to be 4 is 2 times 2. And 2 plus 2 will just not give us 5. So again, making the list I think helps, because then you might always remember, hopefully, that you can always use 1 and the number. 1 times 4 is also 4, and 1 plus 4 will give me 5. Then I simplify if possible. Again, if this is just an x, then this is not going to simplify at all. So my answer would be x plus 1 and x plus 4. And then the -1, which is my GCF, would go in front. So negative and then parentheses. So a common question that we're going to be asked is, would I lose points if I put a 1 in front of the x? It is a really bad habit to put a 1 in front of the x. So some students will want to write it like this, and then 1x plus 4. But you should not, if it's a 1x, that 1 is implied to be there. You shouldn't be writing it in your final answer. Okay, so make sure that for your final answer, it looks like this, and you are just using x. Example 5, 4x squared plus 12x plus 9. So step 1 is to make sure it's in standard form, which it is. Step 2 is to check for a GCF. So 3 would go into 12 and 9, but 4 cannot be divided by 3. 4 and 12 can both be divided by 4, but 9 cannot be divided by 4. So this does not have a GCF. And so that means that we can jump straight into the star. So A is equal to 4, B is equal to 12, and C is equal to 9. 12 goes on the bottom, 4x, 4x, and 4 times 9 is 36. So now I'm going to list out all my factors of 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Everything in this problem is positive. So if the top number is positive and the bottom number is positive, that means you're going to do addition, and both of the factors should be positive. So 6 plus 6 will give me 12. Then we need to simplify. If you have trouble simplifying fractions, Desmos calculator will simplify them for you. But when you're simplifying, you're just looking for essentially a GCF again. What can I divide 6 and 4 both by to simplify this fraction? So I can divide them both by 2, which would make it 3 over 2x. And then this side would also be the same. So those are my simplified fractions, and then I can write those as my factors. So 2x plus 3, 2x plus 3. And that would be my factored form. Now, when you have two factors that are the same, you could also write that as 2x plus 3 squared. We know now that when it's squared, it means that it's times itself. So if you get two factors that are the same, you can also write it like this. So our last example, example 6, x squared minus 11x plus 18. Okay, so it is in standard form, check. It does not have a GCF. If your leading coefficient is 1, then the only thing that you could divide by is 1. So there's no greatest common factor. So we can jump into our star. So A is 1, B is equal to a negative 11, and C is equal to 18. So negative 11 x, 1 times 18 is 18. And then what multiplies to be 18? 1 and 18, 2 and 9, 3 and 6. 2 and 9 will give me 11, but I need a negative 11. So in the event that the top number is positive and the bottom number is negative, that means that both of your signs have to be negative. That would be the only way to be able to add to be a negative, but multiply to be a positive number. The other thing that you can remember is that same signs add. So if you need to add to be a positive, they need to both be positive. If you need to add the numbers together and get a negative, then they would both need to be negative. And these do not simplify any further. So my final answer would be x minus 2, x minus 9.